all of us here actually grew up, not in the age of technology, we grew up in the age of oil, in the age of automobiles, and the age of industry. Those were the precious skills and the precious commodities. Nations actually went to war for oil. And if you go back just 10 years, you could see that reflected. The world's largest companies were all in oil industry businesses. The world's largest was, at the time, was ExxonMobil, an oil company. General Electric was number 2. It was an industrial conglomerate. There were a couple of finance companies in there, and Microsoft. And Procter & Gamble was another giant. It's a consumer goods company. Many of its products were built from the oil derivative products. And if we just scroll forward not long in the history of industry, 10 years, the picture has completely changed. Now the world's largest companies are all technology companies breeding off data. And they're much bigger than the oil industry and automotive industry era firms. Apple is number 1, passing $800 billion in market capital just yesterday. It's twice the size ExxonMobil was 10 years ago. And it's not just Apple, it's Alphabet, it's Microsoft, it's Amazon, and it's Facebook. Every one of these companies is actually younger than I am. Facebook is less than 20 years old. So something fundamental has happened in that 10-year period. It was a switch. It was a moment. But the thing about these switches is that they may seem to happen overnight, but actually they take a very long time. And the antecedents, the foundations are laid many, many years before. If we think back to the internet, I first got online in 1991. There were about 5 million people on the web. Not on the web, sorry, on the internet, and about 1 million in Europe. And in order to use the internet, I'd have to walk to a computer lab where I would get 10 minutes or an hour's time on a green screen accessing the web at 50 kilobits a second. If you scroll forward just 25 years, we passed 1 billion people on the internet, and just 2 years ago, we passed 3 billion. And it's not just the number of people who are on the internet, it's also the quality of our access. It's not one green screen device. We now have multiple devices. In fact, we have so many internet access devices. This Sunday, I was lying on my couch, as I often do, and my phone was in my back pocket, and I couldn't be bothered to reach around to get the supercomputer that I was lying on to access the internet, and I had one of my kids bring me an iPad so that I didn't have to roll over. So we've really come a very, very long way, and as we heard in the previous presentation, it's not just people. We're already outnumbered by the number of devices that are connected to the internet, and we're going to be significantly outnumbered in years to come. But this has actually been really a 50-year journey since the ARPANET was first developed back in the late 60s. But the change happens quite quickly when it comes. And that shift can be merciless or it can be wonderful. If you look at what I'm showing you now, it's looking at the revenues of Netflix and the revenues of Blockbuster. Now, if you were running Blockbuster, there's a point in 2008 where it just looks like your business is a bit wobbly. It's a bit wobbly, change a few of the managers, the stores in Southwest America are not doing very well, change the pricing, we'll fix it, we'll do a turnaround. But oh no, you will not do a turnaround because by 2010 you're out of business. And the question is, how does that happen? And it's not as if Netflix came from nowhere. This overnight destruction of Blockbuster happened in 2009. Netflix was founded in 1997. And what I don't show you on the chart is what happens to Netflix since 2010. It quadruples its revenues. So the shift actually could be an amazing ride, right, if you work at Netflix. If you worked at Blockbuster, it was probably less fun. Where else is this going to happen? I mean, there are too many examples to go into during a short presentation, but 2017 is a key moment in television because it's the year that internet advertising by volume, by value, has exceeded that of TV advertising, the 2017 cross point. Now, there's someone's forecasts from Pricewaterhouse. We don't know if they're going to be correct because they're forecasts, but think about the Netflix and Blockbuster curve, and you can't necessarily be very sure about what happens next. I think there are three reasons why these changes are now seeming to happen so very quickly. And I put them in three categories. The first is that we are in a deployment phase of new technologies, products, and services because we've laid the groundwork of infrastructure, of bandwidth, of devices, of APIs, of coding standards. The second is that many of these underlying technologies improve at an exponential rate. And the third is that these technologies, as we have seen today during Fuel, are converging very, very rapidly. Let's look at each of those. So there's an academic called Carlota Perez who looked at how technology and revolutions deploy throughout history, and she looked at a number and she realized they come in three phases. The first phase is an installation phase. The second phase is a bubble and a recession, and the third phase is the deployment phase. Now, in the installation phase, you get a breakthrough novel technology, and very, very clever people can use it. And so they start to persuade investors that there's money here, and investors tend to invest and build out some infrastructure. Because investors are involved, there's a speculative bubble and there's a crash, and I show those crashes as the gray bars. And after the crash, you get a reconfiguring and you get to a deployment phase. And in the deployment phase, it's a really interesting point. It's a point at which many people need to participate in innovation. It's a point at which we can make use of all the infrastructure that was laid down during the installation phase. So if we look at the oil and automotive and heavy production age, which started in 1908 when the Model T Ford rolled off the production line. That was the same time, and it's not surprising, that oil started to become an important commodity. It was a time of the big oil majors in the US, and it was a time of the Saudi deals, and Saudi Arabia became a country because the West wanted the oil there. And you had the roaring 20s, which led to the Wall Street crash because of speculation. What happened after that process was the post-war golden age in the US. The highways that had been built could now be filled with cheaper cars, suburbs were built, out-of-town shopping malls, hotels, people went on holiday. And there was a tremendous boom that was much larger than what happened in the pre-bubble phase. And so the argument would be that within the ICT revolution, we could well be in the deployment phase because the core technologies have really matured. So the ARPANET, the precursor to the internet, kicked off in 1969. We're now at a point where 3.5 billion people have multiple points of access to the internet. Silicon chips really kicked off commercially with the 4004 from Intel in 1971. We've had our bubbles and recessions, and so we should now be at a deployment phase. And what history tells us about deployment phases is that they happen across multiple industries with a pull of consumers and the utilization of productive capital. But the second thing that's important now, and what makes this particular wave different to previous waves, is that it's fundamentally powered by exponential technologies. These are technologies that improve by 10% every year for the same cost. And outside of the tech industry, we don't really see technologies like this. So Moore's law is the most famous, right? So it's 50 to 60% improvement in the amount of processing you get for every dollar you spend every year. And Moore's law has basically held steady every year for 4 decades. But Moore has some other cousins. There's Kreider's law, which is a 37% improvement in storage on a solid state medium. Keck's law, which is the amount of bandwidth you can shove down an optical fiber. Keck's law, actually 29%, bit of a slow starter, also ran out of steam a few years ago and no longer holds. And Hendy's law, which describes how many pixels you can get in a CMOS sensor that you have in a camera of a camera phone. It's quite hard for us to think about Moore's law, but there's a little experiment you can do, which is if you get your calculator out on your phone and you type in 1.6 to the power xy 40, and the resulting number that you get is the number of times more powerful $1 worth of computing is today than it was 40 years ago in 1977. And it's a big number. It may even break your phone, depending on what you have. And of course, to put that into terms that we perhaps understand, we all carry iPhones, or half of us carry iPhones, half of us carry Android, and someone has got a Windows phone in here, I know it. Is that an iPhone for the same cost today as it was when it launched is 40,000% better if you just look at a handful of the subsystems. So there's 50 times the processing power, there's 6 times the camera resolution. By the way, there are now 3 cameras in it. 6 times the pixels on the screen, and the pixel density is twice as high, and there's 32 times the RAM. But it's the same price. And that is fundamentally what has driven the tech industry for 50 years, and now as every industry is part of the tech industry, it's what's going to drive the kind of changes we see elsewhere. And then there are these converging feedback loops. And the converging feedback loops make this a really exciting, sometimes challenging time. And I'm just going to walk you through them like a clock. So we start with this one here. This is showing the number of CMOS sensors that are shipped globally every year. Now, CMOS sensors are the eyes for computers. They're the things that let your phone see. What you see is that there's a tick up from 2009, when we were shipping 2 billion of these a year, to 2019, when we'll ship 6 billion. So that's a trebling in the amount of visually enabled smart devices on the planet. But Hendy's law is taking place at the same time, with that 60% annual improvement in the number of pixels for every dollar you spend. So by 2019, we see a 300-fold improvement, roughly speaking, in machines' ability to see over the previous decade. If we move across, we look at the amount of data that is being used. And this is just an example to look at the US, where between 2015 and 2018, there's a 7-fold increase in the amount of mobile data that a subscriber uses. This little red chart looks at LiDAR. So LiDAR is a laser radar. It's the key sensor for autonomous vehicles. So back in 2012, LiDAR cost about $70,000. So it's out of the reach for most cars. As of this year, it hit about $250, and it's going down. So the inputs are going down, and what economics tells us is that when the cost of an input goes down, we'll use more of it. Some bits of economics actually work. So up here, we have another component for electric vehicles, which is the learning rate for the lithium-ion battery, which is the most expensive part of the car, I suppose, except for the LiDAR from 2012. And that's improving at a 19% year-on-year price. Then you even get, in other domains, things that move much faster than that. So back in 2000, when we first sequenced the human genome, it cost us about $100 million. For about 7 or 8 years, the improvement in cost followed the curve of Moore's law. That's the white line above the green dots there. And then some novel techniques have come in, and the cost of sequencing a genome has improved far faster than a typical Moore's law curve. And now it's down to about $10,000 per person, per genome. So what was a significant national research spend has now become something that a reasonably wealthy person living in the West could just decide to do if they wanted to. And so this combination of the deployment phase with these exponential technologies that are highly converging is creating a set of really interesting innovation equations. And they're innovation equations because they knit together some of the other pieces, separate pathways. So a good example is augmented reality. Right? What is allowing augmented reality to be a thing today? Right? It's not that a bunch of AR people sat down and just thought about the full stack. They had a bunch of technologies they could draw upon. And in the case of AR, there's the smartphone dividend, the dividend of the smartphone wars. There are billions of devices that are strong enough and powerful enough to run the processing that you need, because a phone has got a very powerful CPU and an even more powerful graphics processing unit in it. And phones also have cameras, so they have eyes, and they have high density, high color, fast refresh rate screens, so they can present the information back. But augmented reality and virtual reality also needs advances in AI, because you need the machine vision. You need to be able to identify an object in an image. You need to be able to segment it, that is, pull it out of the image. You may even need to be able to complete the image by predicting what's happening at the back of the image where you can't see the photo. And so the work in AI is bringing those technologies to the fore. And then finally, particularly with virtual reality, you have the video games dividend. So you thought that all that video games was just keeping teenage boys off the streets. In fact, it was helping us develop software tool sets that will allow VR and AR developers to ultimately deliver the experiences that we see. So it's an example of a converging innovation equation. You also have, in another area, the space insights equation. We just heard about the boom in low-cost startup space innovation. But it's turning into new types of businesses. So here's an example of a company called Orbital Insights. They take satellite photography and they look at the car parks of retail malls, retail stores. And they count how many cars there are in there. And they use those car counts as a way of predicting retail sales and therefore future stock price. And the black line is the car count, and the green line is the share price. And if you're a hedge fund manager, that black line is super, super interesting. Now, how has Space Insights been able to do this? Well, they've been able to leverage the Earth observation satellite industry, which was tiny 20 years ago and is now getting larger and larger and exponentiating as well. Because not only are there more operators of constellations of satellites, the constellations of satellites themselves are getting larger. There are more satellites within them. But of course, you can't do that without the breakthroughs in AI and machine vision again. And you can't do that without the access to the digital mapping that we've built up over the last 10 to 20 years. Layers upon layers upon layers. Even in agriculture, you have something similar going on. So there's a startup called Blue River Systems, which combines sensors and robots and AI to help farmers optimize their lettuce crop yield by 10% every year. It's quite significant. And it's a form of precision agriculture. And how's that being pulled together? Well, again, they're not building a system end to end. They're able to take advantage of the innovations in AI. They're able to take advantage in the innovations of sensors and IoT, combine them with digital mapping data for geofencing, and combine it with drone and robotic technology that is being created elsewhere. And there you have the ag-tech equation. But we couldn't have this discussion without talking about the blockchain. And we had a great panel and session on the blockchain. I'm just going to look at one aspect of it that I think is particularly interesting for media companies. So what's happened over the last 20 years is that the beautiful future of the internet, which was always going to be about distributed systems and no central control, has been sullied by the arrival of the GAFAs, Google, Amazon, Facebook, and Apple, and their ability to secure a central position in the network and become dominant and become monopolists. And that creates a whole bunch of problems because monopolists monopolize, right? They rent seek and they under-innovate. So the promise of blockchain is that through this distributed ledger, you can go ahead and get the kind of end-user benefits in a network that a platform used to have to provide, but you can do so without needing the platform. And that's got the pretty sexy title of the re-decentralization thesis. But in amongst all of this, what we are seeing is an acceleration of deployment. Because of the deployment phase, the exponential change, and the convergence, innovations are getting to market much faster. This data set looks back over 200 years. It's from an analyst called Horace Dediu. And what you see is that the amount of time it takes these innovations to ride the S-curves is getting faster. The curves are getting steeper. So in the 1800s and the 1900s, the curves are reasonably flat. They're getting steeper and steeper, and there are many, many more of them, which is what you'd expect to be happening. And if we go and just zone in on what are the technologies that deployed in 10 years or less, they're all recent technologies. So it's like a lake where we're throwing stones at them at a faster and faster rate. And the interesting point is not the stone, the interesting point is the ripple effects. And here are the ripple effects, just thinking about autonomous electric vehicles. Well, if you have autonomous electric vehicles, you don't need petrol stations, so what are those companies going to do? What are the businesses that lent money to them going to do? What's going to happen to the real estate? Autonomous vehicles and EVs don't need repair, so auto repair shops will need to find something else to do. But many second-hand car resellers make their money from auto repair, so what will they now do? What happens to urban planning? What happens to cities which have been designed for long commutes, particularly an issue in America? Much of retail has moved through to the assumption that people will drive somewhere in order to have an experience day. And the insurance industry needs to change as well. So these second, third, and fourth order effects may often be bigger than the first order effect of the stone that you put in the lake. So how do we look forward over the coming years? Well, there are going to be thousands of startups. I think we've recognized that startups are the best vehicle for capturing this kind of innovation and for commercializing it and putting it in front of customers. And now we have established startup networks, angel investors, incubators, VCs. Corporates participate in about a third of all venture financings. So there are going to be thousands of more startups. There are going to be millions of job shifts as well, because with AI coming in and starting to automate work as a new technology, job roles will change. And there are two futures. There's one future which is that says AI is just like every other technology we've had. It changes people's jobs, but it creates new jobs. So yes, there are no blacksmiths, but there are now many more taxi drivers. The second future is that AI will come in and create robots that are so smart they can do everything better than a human, even be a human better than a human. And there'll be lots of output, but there won't be much work. So it doesn't matter which of those two futures there is. There's one thing that is certain. Millions of people's jobs will change. And they will face the uncertainty, because a job is what often gives people a sense of identity, not just income, but self-worth. And jobs often hold communities together. And that's a big challenge for us. There'll be billions of new users for these new services. We know that now because every man and his dog can create an app that will get 10 million users and no one will be interested in it. You know, 1 billion is the new 10 million. And outside of the GAFAs, you've got the Baidus and the Ubers and the Netflixes, all angling to be services that serve 1 billion plus users at a time. And the final thing is that there'll be trillions of dollars of value that will shift. When I started this presentation, I showed you what had happened to the biggest companies in the US. That represented $2 trillion worth of value moving over. But it's estimated that 75% of the S&P 500, the 500 biggest companies in the States, will change places in the next 10 years. That's tens of trillions of dollars of value that will shift, which will create tremendous opportunities for innovators like us. And so I think it's a great time with lots of opportunities and time to dive in. Thank you very much.